John Napier was born in 1550 in Merchiston Castle, Scotland. He was born into nobility and lived in Merchiston his whole life. Napier was tutored until age 13 when he entered the University of St. Andrews. His college career was short-lived, as believed he left without a degree and traveled the world before returning to Merchiston to live the rest of his life. There, he had 2 kids with his wife Elizabeth Sterling, and later, after Elizabeth's death, married Agnes Chisholm, with whom he had 10 more children.
Napier, to say the least, was always passionate about his interests. This trait of his allowed him to focus on tedious mathematical procedures for 20 years, even when he viewed mathematics as simply a hobby. Napier was also very passionate in his Protestantism. The committee that he was part of in the Scottish Church once asked for justice to be done against the enemies of God's Church. When they said enemies of God's Church, they meant the Catholics.
Gifted with a steadfast personality as well as mathematical prowess, Napier was able to accomplish almost anything he set his mind to. Given that Scotland was anticipating an invasion by Catholic King Philip of Spain, Napier set out to create military inventions in defense of God and country. The inventions included a sun gun, artillery, and a metal chariot. The sun gun was a concave mirror with the intention of focusing the sun's rays to cause destruction, and the metal chariot is what we call a tank. However, these inventions were never constructed.
Among Napier's inventions were 2 ways to simplify complicated mathematical operations to simpler ones, one of which is integral to calculus. Hey Joel, how's it going?
Hey Daniel.
Boom. What are those?
These are Napier's bones.
You have Napier's bones?
No. These are just a tool to make multiplication and division easier.
So, how do they work?
Alright, so say I wanted to multiply, say, 81 times 4.
Okay, because that's what I want to do.
So for the first place digit, you would take the number on the right side, so this would be a 4. And then you'd add up the next 2 columns, that's a 0 and a 2, so that's the tens place is a 2, and the hundreds place would then be a 3. So then the answer to 81 times 4 is 324.
Wow, but can't you just use a calculator to do that?
Well, in Napier's day, they didn't have calculators, so they had to use other tools to make multiplication and division easier.
Oh, okay. So how did Napier create this?
Well, this is based off of Arabian lattice multiplication, which was very commonly used in Europe in the day.
Oh, okay. All right. Well, now I know how to use Napier's bones.
Exactly.
Thanks, Joel.
You're welcome. The mathematician and inventor's most famous and influential work, however, is his invention of logarithms. John Napier published his famous work Mirifici Logarithmorum Canonis Descriptio, or a description of the wonderful table of logarithms in 1614. This work represented a culmination of 20 years of calculations and introduced the idea of logarithms to the world.
The word logarithm comes from the Greek and Latin roots logos, meaning reckoning, and arithmos, meaning number. He was able to use these reckoning numbers to reduce complicated multiplication and division to simpler addition and subtraction.
I'll show you an example of how logarithms can be used to simplify multiplication problems. So let's take an example of, say, 120 times 34. So I want to know what that equals. You could do this with a calculator pretty easily, but in Napier's day they didn't have calculators, so multiplication problems, even with bigger numbers, could take a long time. So I use this method to shorten it. So I'll use base 10 for this. So if I say find what power of 10 120 equals, that's going to be 2.079. And if I find what exponent 34 is, it's 10 to the power of 1.531. So if I take this, I can just add these exponents. So this will equal 10 to the power of 3.610. And so what is 10 to the power of 3.610? This equals 4,080. Let's do a quick check to see what this equals. So what does 120 times 34 equal? Well, there you go, it's 480. Napier's form of logarithms is different to the commonly used base 10 or base e. He used a different base for his calculations, 1 minus 1 over 10 to the 7th raised to the power of 10 to the 7th, or approximately 1 over e. We will show you a simple example of how this worked. So now I'm going to show you how Napier was able to create his tables using a more simplified example. So Napier used this base, which is huge and also very accurate, we're going to use the base of 1 minus 1 over 10 to the 10th. So now I'm going to show you how to find the logarithm of, so let's call this a. Let's go a to the point 1, right? So this is equal, we're going to take this, 1 minus 1 over 10 times to the power of 10. We're going to raise this to the point 1. Right, so here you can just multiply the exponents. So then this is going to equal 1 minus 1 over 10. And then 10 times 0.1 is just 1. So then this is going to equal 1 minus 1 over 10, which is going to be 0.9. So then we can do this again with 0.2. So a equals a to the 0.2 equals 1 minus 1 over 10 power of 10, and then we're going to raise this to the 0.2. So this is going to equal 1 minus 0.1 squared. So we can also think of this as 0.9 times 1 minus, or times 1 minus 0.1, or 0.9 minus 0.09, which is going to equal 0.81.
Though these calculations may seem quite feasible, using a higher power for more accuracy took a long time, especially because he used the base of 1 minus 1 over 10 to the 7th raised to the power of 10 to the 7th. In fact, these calculations took him 20 years to complete, but his hard work and dedication paid off.
Mathematician Pierre Laplace once said that Napier's discovery doubled the life of the astronomer. Logarithms were welcomed with enthusiasm by astronomers who needed to make calculations with large numbers quickly and accurately, where previous methods were prone to errors.
Mathematician Henry Briggs took notice of Napier's work and traveled to Scotland to work with him. Briggs convinced Napier of the value of using base 10 logarithms and revised the logarithmic tables to make them easier to use. John Napier's discovery of logarithms changed mathematics forever.
His legacy is honored through Edinburgh Napier University, a public university in Edinburgh, Scotland. Napier set the foundations for much of the calculus we do in this class. He has made a significant impact in the world of mathematics and science.